So ultimately, the conclusive part was scaling up was with respect to there was a computation time and communication time, and whenever he scaled up from four processors, he modeled it so that 20% of communication for four processor of some problem statement was there. So and hence why it is taken point it is that 80% of the time it is spent in communication. So whenever you speed up the 32 processes and a ratio was evolved, somewhere which indicates that you are spending somewhere around 85% of the time in the communication whenever you scale up a processor. So I think we quoted two laws, the guiding principles, Hamda's and the Gustafson's law. So scaling for problem statement as well as number of processors, and bottleneck with respect to the how much things can be really go into parallel. Or sequential bottleneck was referred to with respect to Hamda's law. So after that, we'll be moving to the next scaling of with. So we noted something with respect to spin lock. What is spin lock? So spin lock is an approach where you don't suspend yourself. You don't go or move out of the ready queue from your OS. So whenever the thread or task is scheduled, so how it goes. So basically, it is queued in a ready queue, and as and when the scheduler decides, so something of the task of thread, whatever you can call it, is moved from that queue to and allocated a processor and goes for a running. So most often, when the spin lock was implemented more often with respect to OS perspective, if I start speaking, the context switching times are somewhere very much near to the waiting periods. So if I have to context switch means I wanted to go for running, so some processor wanted to occupy the processor and execute its stuff, but the resources wanted is not available, and hence you are moving out so that you back up. So there was a push pop operations with respect to registers or context switching. Then again you have to come back through ready queue takes a lot amount of time because there are contenders and the next time you are in a queue it takes a lot of amount of time. So if you can make it happen so that you can be there waiting, doing nothing, or some no operations were incorporated, and you wait till that resource is allocated, and you are not moving out of the ready queue, and that's what you are executing, no operations. So once the resource becomes free, and you start executing it, and you are not ultimately you are not suspending yourself. In that case, spell works are implemented. Um, through which you continue to run. So the director bus acts as a point of serialization. So that what is meant by point of serialization is um, there cannot be parallel approach of parallelization whenever you want to access a particular resource. So something has to have a serialization. Suppose I just want to give an example for that matter is if you think everything has to go in parallel, think from the perspective of bank transactions. Suppose my father is depositing some 10,000 in my account and almost at the same instant I'm withdrawing 5,000. Now, what is the variable? So, the remaining balance of my account should showcase. So, in that case, there is a serialization. You are not executing them as a parallel. You make a device on banking software or whatever. The algorithm is basically you should serialize that kind of processor so that the data integrity is made intact. One algorithm or the one convention they have adopted with respect to bank is deposits are given a higher priority compared to the withdrawals. So a deposit happens first, then the withdrawal happens. So it is serialized. It is not executing things simultaneously. Even though I entered a pin or whatever the transaction can be, almost happen instantaneously. The thing given higher priority is the deposits and then the withdrawal for all processor leading to lots of contention as well as traffic. So that whenever you have say that serialization, that means you are compelling a queue for all contenders who are ready to access the things parallelly or in contention create parallelly. So and hence whenever there is a contention or arbitration has to take place and then you decide so you go next or I go next that kind of stuff. It's not a simple queue. Now the priorities and deadlines are things that will come pop up in that particular arena as such. So you can read actual read and write log head in the cache. So that's where linked operations access to the code how many um, what is it? basically again he wants to prove the point that there is a lot of communications whenever you just think of increasing the number of processes with respect to problem statement or problem space. So scaling up of a problem is just a concern, and as you increase the processor, yes, the computation with respect to each processor may go down, but the communication overhead and the contention, because communication by itself is a complex problem statements. Who will communicate to what? How do you form the grids? Basically, we have shown some grid layouts and processor 1 speak to processor 2, processor speak to processor 3, and some rough informations were there. But whenever you ask me to, can you define with respect to particular application like FANS application, Ocean, or FFT, or ALU algorithms, or will be bit difficult. That means you have to jump into that particular domain and then why you have created so many grades of horizontal or vertical columns and who is speaking to what, how the problem statement is divided. That leads to a lot of complexity that is not discussed as a part of this textbook. But he just quotes them, and there's a grid formation, and whenever he's I load linked operations of the what is it, load linked and store computations. So why? Uh, so what happens is, how does 2I plus 1 comes into picture? So that is with respect to the number of iterations how things are executed. Okay, let me just go to that. It's not responding. Okay, hang on here. I just want to continue. There's a locking of the variable whenever you want to operate exclusively. So most oftenly there were instructions mentioned in that assembly code called as a load linked and store conditional. So what you are defining is atomic operations. What is atomic operation is whenever any one processor is operating on that particular memory locations or variable, so no other processor is allowed to do so. There was with respect to that unlocking information. Then there were barriers so that you can go ahead with respect to executions, but you cannot go further until everybody finishes. So there can be some parallelizations. That's a barrier. Now the third level he created a what happened? Level sensitive event. ಅಲ್ಲಿ ಲೋಕಲ್ ಒಂದು ವೇರಿಯಬಲ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾನೆ ಸೊ ದಟ್ ವೆನೆವರ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರೊಸೆಸರ್ ಇಸ್ ಆಕ್ಸೆಸಿಂಗ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಲೊಕೇಶನ್ ಸೊ ನೋ ಅದರ್ is allowed to manipulate it. Give me 10 minutes. So problem side, then so this is where we were discussing say. So then barriers were discussed. So barrier synchronization so that there is a release or lock release will happen only whenever everybody finishes. So with respect to that, some code manipulation was being done. So earlier the locking variable. So within the lock is atomic operation. Only one can access that particular stuff. So whenever everybody finishes, so you have to wait until everybody finishes. That is what is happening in the spin. So release one happens whenever everybody has finished. So if count is comparable with the total, then you are making the count as 0 as well as you are releasing the stuff. Right? So that is a barrier indication. There was a problem with respect to barrier if at all because it is incrementing on every iteration. If count is not equal to 0, whenever you are locking that release 0, if yield number, so count is equal to count plus 1. So that means on every iteration you are incrementing that particular stuff. It may so happen that due to parallelization, if you have one thread which has crossed or completed first lane, then it jumps to the second lane or so many iterations. So due to parallelization, it may finish off early, incrementing the stuff. So that now the remaining who have not completed the lane automatically starts missing their chances. So because barrier sees that somebody has completed and one fellow is not coming at all. So because he has already come, but uh, that's where fast processor traps remaining slow processor in the direct resetting flag release. So flag is released without a completion. So somebody comes late, now he is supposed to go to the next lap. Reality is he has not completed the earlier one. That's how the impression of the barriers can fail. So what is the next alternative? We go for a sense reversing barrier, or there is a local variable with respect to whatever the threads you have created, and there only the release option is comes into picture. Local sense of the great control. So this local sense is between this lock and unlock. If you can just know that local sense toggles the it's a toggling variable. So whatever the operations are happening with are within the locks, lock and unlock, and that variable is within that. Whenever all the local senses are released, so then spin releases of the sense reverse barrier, whatever the nomenclature is making sure that everybody is really completed. So, whereas the simple barriers case, there can be chances so that some suffers with that. So, we assume load linked and store conditional. These are the facilities that are expected or made available by the processor. And again, he gives example for 10 processors, execute barrier simultaneously. Each processor has a bus transaction of 100 clock cycles to reach the barrier, we list the barrier exit barrier. So how many times the things are happening? So whenever you say 3i plus 4, how do you get it? So again, he is referring to table. So you accumulated, you are accomplishing the load and store conditional. So on every iteration, so the number of processors. So if you are considering n number of processors, so on every ith processor, if you are considering the operation ಏನಾಗ್ತದೆ. So I plus I load linked ಒಂದ್ಸಲ ಮಾತ್ರ load ಮಾಡ್ತಾರೆ. Maybe the last instruction you are not loading. So because the count has already reached. So you wanted to count till 10 numbers after that, and that is not going to happen. That hence I minus 1. So whenever you add this, so 1 equal to 3i plus remaining whatever 2 plus 2 4. So and hence this happens. 3i plus 4 is the iteration, and with respect to all iterations, how much it is going. So again, convergence series, you compute it, and 3n square, whatever the number follow. What is interested for us is so 10 processor. This is a 204 bus cycles of 20,000 and odd clock cycles. That is a fair and large time that processors are being made to date. That is as good as twice as long as 10 processor with earlier approach lock and unlock the processor. Now we are using the individual sense lock and unlock. So third approach with respect to that is then they form a tree kind of architectures where whenever you want to work operations and the related transactions are made as a higher lock side. One there's a higher node and finally there's a float node. Whenever one suspends, the remaining all the leaves of the nodes are suspended. That's the last approach where that local copies are made with respect to the one node tree. So leaflets with respect to node tree, and that are accomplished, and hence you can reduce the number of bus transactions. ಎಲ್ಲಾನು simultaneous ನೋಡಬಹುದು. So there is a tree architecture that is devised so that the number of bus transactions or bus computations can be reduced, so that at least some processor can go faster. So all the content, everybody is contained for the same mode. The smaller groups and then achieve the target, divide and conquer kind of approach. One to initially read and to operate simply spin. Just read the highlighted points. Just cover with your head down. Depends only on the latency of the uncontained is that it would take 1,000 rather than 15,000 cycles to complete synchronous operations. So we have reduce that number of cycles. Now, software mechanisms to synchronize mechanisms larger delay due to unconditioned when spinning on the log. So major difficulties are delay due to contention when many processes are spinning on the log. And it's some kind of greedy approach. I'm not suspending myself because I hope that immediately if somebody is using it, after he releases, I will be occupying that. What I don't realize, or whenever that particular node of processor doesn't realize is, also there are many contenders who is hoping for the same. When failed to acquire a lock. So delay a process when failed to acquire a lock. It is somewhere similar to if you have learned CSMACD in your communication protocol. So if you can remember, what is CSMACD? Carrier Signals Multiple Access and Collision Detection or Collision Avoidance Protocol. Can anybody tell what happens over there? The same approach. So he's just using the same different wordings for that matter. So if anybody can elaborate that, I'll be happy. Yes, Shweta. Yes, please. So there is a back off. So everybody or every transmitter. Again, I'm right now I'm explaining CSMACD, and I will come back to this particular code or concept as such. So every transmitter or everybody, the transmitter or receiver, is listening to the channel. So whenever that message is broadcasted, everybody listens to it. Whoever ನಿಜವಾಗ್ಲೂ ಯಾರಿಗೆ ಮೆಸೇಜ್ ಟಾರ್ಗೆಟ್ ಹಿಡಿದು so he will listen to it and more meaningfully. Otherwise, everybody just listens to the channel. So carrier sends multiple access because everybody is listening, or the media is accessed by many users simultaneously, and hence multiple access. Then whenever two transmitters transmit, so the normal signal levels of the nominal voltages of that particular channel goes or above, below certain nominal voltages or currents. So then you realize there is a collision. So simultaneously two have transmitted. Then how does every transmitter will make sure that whatever he speaks is reaching the other end? So they will go for back off. So back off timings for every node is different. So back off andre, so ನಾನು ಮಾತಾಡ್ಬೇಕಾದ್ರೆ ನೀವು immediately if you say two speakers start simultaneously, what is the normal approach we do? We keep silence for a certain amount of time. So if we start speaking simultaneously or in Google Meet or whatever the communication media, ಏನು ಮಾಡ್ತೀವಿ ಇಬ್ರು ಒಂದೇ ಸಲ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ, so both of us will try to keep silence, so we will not transmit anything, so that until the channel becomes free. Now the backup times are with respect to individuals are different. So I may keep quiet for 10 seconds, you may keep quiet for 5 seconds. So similar things happens over there. So what is happening is the special instruction DSLL, whenever you increase the delay by factor of 2 or the exponential delay. So whenever you attempt to lock and the lock is not available, then you back off for certain amount of time. So the more you attempt, the more waiting you will undergo, because it is doubling for every iteration, so, and hence exponential back off time. So you try to attempt a particular register load in order to the lock ಮಾಡಿ try ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ, but it is not happening. So then you jump to that DSL, so increase the delay by factor of 2 and then try to lock it again. So you want to lock it up, as in case of a CSMACD, you want to transmit something after certain backup time. Now that backup time, if the initial attempt was unsuccessful, now I increase my time by 2. Now my second attempt is also unsuccessful, I increase my waiting period to 4. And that is what is exponential backup. So that is what is implemented even whenever you are locking, whenever there are many processors, so they want to try the same resource or lock the same resource. Okay. Just read it. So when a store condition fails, the process delays by itself by the value in arbitrary. I just want you to read this paragraph and then read the code. Okay. Is to queuing logs. Queuing logs is it is as good as a separate queue as you see that ready kind of architecture. So whenever you want to lock a particular resource, a particular data structure called as a queue is created. So that you want to log something, yes, you have to wait in a particular queue. So it causes the next process in the queue to attempt. So if I consider CPU as a resource, or memory as a resource, now the same thing. So for CPU I call it a scheduling, and resource I think is that's a resource queue. So that you are allocated resource on a particular queue basis. So that is again fair enough kind of a system if you can imagine. There is no priority whenever I'm saying queue. So every processor, or say every process, whatever it is containing for resource, is going into a queue. So he's not discussing anything with respect to priorities as such in this particular aspect. So para implementation suffers condition during both gather stage as well as must automatically update the count at the release stage. So gather stage is, as we have stated, you back up for so many attempts so that you are backing off exponentially. After you gather that, then some iterations will go on which are happening automatically. So what is meant by automatically is you are not interrupted. That particular process has to run at once or run for completion. Cannot be intermediately interrupted. So store stage or that is the release stage. Store conditional or book condition is given. So gather stage is more serious and creates a much more tougher job for serialization. That means only one should get the lock at a given point of time, and there is a sequential hurdle. So serialization that has to be adapted sequentially. So that has reduced by combining a tree structure where multiple requests are locally combined in a tree fashion, so that all competing for a particular node within the. So you group a particular nodes with respect to resources or whatever the mechanisms, so that the requests or contentions can be resolved at that state level. It is as well as decentralization or delegation of jobs as such. So don't compete for all the resources at once. Maybe some local obstacles, with the dump factor, bulk factor, then Jilla factor and the higher administration is kind of scenarios. Or we can just imagine a tree structure so that we just use example. I request you to go through that technical example because explaining that will be more tedious. I have to remember the nodes and what is happening really. If you know the background of framework, you can read. I think that will be more sufficient as such. So then we will release all the waiting processor whenever it arrives at a route. Release multiplies in our earlier example. We will sense reversing technique. That means local variable at that particular leaf level of node level. On the node in the release mode, you make it available for the particular request. Build to hardware synchronization primitives. The first primitive deals with the logs, and while the second is with respect to barriers. So implementing in terms of hardware. So hardware primitives is the primitive is basically a small structure or circuit which accomplish the tasks much faster. Normally, software approaches are slower because you have to wait till whatever happens with the data assembly code that has been generated. So hardware primitives where latency is essentially identical to our earlier versions, but with much lesser serializations, leading to better scaling when there is a condition. So log is released, all processors generated both read and write mixes. Now somewhere the same stuff is being explained before looking into the code. Make sure that whenever you are reading this, make it a habit, read the paragraphs first and then read the code. That gives a more comprehensive reading. using nodes in the array tree. Each node in the tree combines k processes completing, so we form a smaller groups, provides a separate counter and a log. So that is separate whenever most k process one now we are creating particular groups. In the tree, it goes up to the parent, so root. So finally, one process on the parent root. That's where the entire things are being resolved. So software implementations again. Harvest so then form a tree, that is our implementation, and the computation, number of cycles. Again, one more example. Ultimately, everything boils down to the cache, and the finally memory architecture has to be brief about. I have explained. So code was case sensitive where you are using fetch and include to do counting. So where exactly the algorithms starts failing or they are compared to the scientific applications, again it goes back to the same care, say LU, FFT or ocean burns algorithms. I'm not going to details, say, so how much they have executed 130 grid or 140 grid. So I'm just going for the core part or the graphs, which are more interesting. So whenever you are going for that, so there's a coherence miss rate and capacity miss rate. So capacity miss rate, so he states that compulsory misses are also included in the capacity misses. Otherwise, with respect to cache miss, whenever you are discussing, there were three misses. One was compulsory, conflict, and capacity. So compulsory is whenever the system is reset or the initially it starts putting, nothing is available in the cache. Now to fetch something lower order memory to fill it. So that is bound to happen and it's unavoidable. Conflict basis, this is normally happens with respect to the type of cache you are choosing. So whether you are choosing a direct map cache or the two-way set associative or fully associative kind of caches, and the one more terminology has been introduced in this particular graphs is with respect to coherence message. So capacity is because of the whatever you want to accommodate in a cache is not available. The block size is larger and you require a large cache. That is capacity. That's what is incorrect. If you had a huge cache, so entire all the variables, whatever the data required for my computation is readily available, almost at the register fetching time available. Then it is called as for that capacity is being enhanced. So if it is not available, then you have to flush one or the other block from the your cache cache material. So one of the other block has to be flushed. So the cache cannot have cache miss. So that leads to cache penalty or misselect or penalty that occurs. So penalty is normally higher. And what is observed across this is again whenever you are interpreting, let's say capacity misses have been reduced except for ocean. So ocean की 20% करके होते थे से whenever you consider with bonds and FFT at value again. So somewhere below 10 whenever you are considering. So that has happened with respect to enhanced cache. So enhanced cache in the sense, so you are not increasing the cache. So whenever you are increasing the number of processors, every processor comes out with respect to their own cache or private memory, and hence the cache can be enhanced. But now, because of that sharing of the data across the processor, it may happen that the data consistency is lost. So something right back or right policy, then you should maintain that data integrity or data duplication intact. So that if it is not happening in that scenario, you say that is a coherence miss. So cache coherence has failed. So that forms a major deviation from the single scalar processor to multiprocessor. So you are incorporating one more miss rate or one more kind of miss, that is the coherence miss. So that seems one of the aspects. So because compulsory misses are almost negligible whenever you are considering the misses, that has direct part. That is not showcased over here. So whereas the coherence miss starts occurring, and capacity means with respect to data types. So what kind of data that the ocean is dealing with? So in the paragraph, what he is elaborating is how much connected or how much special of the temporal locality is made available. So with respect to FFT, LU, or ocean. So there's a different kinds of, so how much you are interacting with respect to other nodes, and how much data is spatially and temporally available will alter these aspects, FFT and ocean. If most of the data, whatever I want to work with, they are readily available, then there are lesser capacity misses because you have enhanced the cache size. Not single on a single processor, but every processor is contributing to the cache pool of the system as such. I think we'll stop here and then continue the next class. So again, few more graphs and. So meanwhile, if you have prepared anything with respect to the last chapter, arithmetic. So from next class onwards, if I can do say almost 20 to 30 minutes, I will take class, and the remaining if you can go on handling. So arithmetic circuits. So that would be better. Are you prepared for it?
Sir, preparing, sir.
Hmm.
Sir, we are having other seminars, sir. Advanced and project and VLSS, sir.
Okay.
Subject, sir. So kindly take it from next week, Tuesday onwards.
ಅಲ್ಲ ನಿಮ್ದು ನಂಗೆ ಗೊತ್ತಿಲ್ಲ ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಇಸ್ ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಲಾಟ್ ಆಫ್ ಟೈಮ್ ಫಾರ್ ದಿಸ್ ಅದರ್ವೈಸ್ ಐ ಕ್ಯಾನ್ ಸ್ಕಿಪ್ ಇಟ್ ಬಟ್ ಏನು ಚಾಪ್ಟರ್ ಹೇಳ್ತದಲ್ಲ ಇಟ್ಸ್ ಮೋರ್ ಆಫ್ ಡ್ರೈ ಸಬ್ಜೆಕ್ಟ್ ಆಸ್ ಸಚ್
Yes, sir.
there are only paragraphs and I am not able to find any slides so that I can finish it off faster. I have to read a lot and deliver less. That's what is happening. On the done problem ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಷ್ಟೆಲ್ಲ ಓದಿ ನಿಮ್ಗೆ ಹೇಳ್ಬೇಕಾದ್ರೆ ಅದು 10 ನಿಮಿಷ ಮುಗಿದು unnecessarily I feel I am dragging the content more. So otherwise there is nothing as such. The last appendix chapters ಏನಿದೆಲ್ಲ most of all the appendices are almost something similar to that. Where the hardware computation ಯಾವ ಅಪೆಂಡಿಕ್ಸ್ ಡಿ ಎಚ್ ಐ ಅಂತ ಏನೋ ಬರ್ತಲ್ಲ ಸೊ ಐ ಆಮ್ ಫೀಲಿಂಗ್ ಮೋಸ್ಟ್ ಆಫ್ಲಿ ದ ಟ್ಯಾಗ್ಡ್ ಕಂಟೆಂಟ್ಸ್ ಆ ಥರನೇ ಇದೆ ಅರ್ಥಮೆಟಿಕ್ ನಿಮ್ಗೆ ಯಾಕೆ ಹೇಳಿದ್ದೆ ಅಂತಂದ್ರೆ ಸೊ ಮೇನ್ಲಿ ಯು ಆರ್ ಅವೇರ್ ಆಫ್ ದಟ್ ಆಡರ್ಸ್ ಫ್ಲೋಟಿಂಗ್ ಪಾಯಿಂಟ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಆ್ಯಂಡ್ ಸಮಥಿಂಗ್ ಯು ಹವ್ ಆಲ್ರೆಡಿ ಅಟೆಂಪ್ಟೆಡ್ ಇನ್ ಯುವರ್ ನಾರ್ಮಲ್ VLSI ಕ್ಲಾಸಸ್ ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ಐ ಫೆಲ್ಟ್ ದಟ್ ಯು ಕ್ಯಾನ್ ಹ್ಯಾಂಡಲ್ ದಟ್ ಅದಾದ್ರೆ ಮುಗೀತದೆ ಇಲ್ಲ ಅಂದ್ರೆ ಈ ಪ್ಯಾರಲ್ ಆಗಿ ಹೋದ್ರೆ ವಿ ಕ್ಯಾನ್ ಫಿನಿಶ್ ಆಫ್ ದ ಚಾಪ್ಟರ್ ಅದರ್ವೈಸ್ ದಟ್ ಬಿಕಮ್ಸ್ ಅಂದ್ರೆ ನಾನು ಅದನ್ನ ಕಂಪ್ಲೀಟ್ ಅಂತ ಹೇಳ್ಕೊಳ್ಳಿ ಬರೋದಿಲ್ಲ ಅಷ್ಟೇ ಸೊ ವಿಲ್ ಟ್ರೈ ಇಟ್ ಪೋಸ್ಟ್ಪೋನ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ ನಮ್ಗೆ ಲಾಸ್ಟ್ ವರ್ಕಿಂಗ್ ಡೇ ಯಾವಾಗ ಕರೆಕ್ಟ್ ಗೊತ್ತಿಲ್ಲ ಏನೋ ಎನಿ ಐಡಿಯಾ ಸೊ ಐ ಥಿಂಕ್ ಡಿಸೆಂಬರ್ 20 ಅಥವಾ ಇನ್ನೂ ಅಂದರೆ ಈಗ ಆಲ್ರೆಡಿ ನಮ್ದು ಎಷ್ಟನೇ ತಾರೀಕು 12ನೇ ತಾರೀಕು ಅಂದರೆ ಇನ್ನು 3 ಕ್ಲಾಸ್ ಸಿಗ್ತದೆ ಈ ವಾರ ಅದನ್ನ ಬಿಟ್ಟರೆ ನೆಕ್ಸ್ಟ್ ವಾರ ನಿಮಗೆ 18ರಿಂದ ನೀವು ಏನೋ ಒಂದು ಪ್ರಾಜೆಕ್ಟ್ ರಿಲೀಸ್ ಆಯ್ತು ಅಂತ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀರಿ 26 ಅಷ್ಟು ಮೋಸ್ಟ್ಲಿ ಥರ್ಡ್ ಡೇ ಇರ್ಬೋದು
ಸರ್ I2 ಮಾರ್ಕ್ಸ್
ನಾ ಹೇಳಿದ್ನಲ್ರಿ I2 ಕೊಡ್ತೀನಿ ನಾ ಬುಧವಾರ ಅಷ್ಟೊತ್ತಿಗೆ ಕೊಡ್ತೀನಿ
ಥ್ಯಾಂಕ್ ಯು
Sir, we'll give it on 22 December, sir. Tuesday, sir.
ಎಲ್ಲರೂ ಒಂದೇ ಸಲ ಮುಗಿಸ್ಬಿಡ್ತೀರಿ
ಎಲ್ಲರೂ ಒಂದೇ ಸಲ ಮುಗಿಸ್ತೀವಿ
ನೋಡ್ರಿ ಇಟ್ಸ್ ಯುವರ್ ಪ್ಲಾನ್ ಅದರ್ವೈಸ್ ಇದು ಮುಗೀತಂದ್ರೆ ನಾನು ನೆಕ್ಸ್ಟ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ ಮುಗಿಯಿಲ್ಲ ಅಂದ್ರೆ ಅಷ್ಟೇ ಅಂದರೆ ಅಗೇನ್ there are only graphs from now onwards so again tree and other structures whatever he is stating ನಿಮ್ಗೆಲ್ಲೂ ಗ್ರೇಡಿಂಗ್ ಇಟ್ ಅಂತ ಏನೋ ಕಾಣಿಸೋದಿಲ್ಲ he just says so many grades and the number of nodes have been increased or decreased ಒಂದು ಯಾವುದೋ ರೋಟ್ ಏನೋ ಅಂತ ಏನೋ ಪ್ರಾಬ್ಲಮ್ ಕೊಡ್ತಾರೆ that's what again I feel that is most of a biting issue as ಕಾನ್ಸೆಪ್ಟ್ ನಿಮ್ಗೆ ಗೊತ್ತಿತ್ತು ಅಂದ್ರೆ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಎಕ್ಸಾಮ್ ಬರೀಬೇಕು ನೀವು ಬ್ಯಾಪೆಟ್ ಮಾಡ್ತೀರಿ ಮಾಡಬೇಕು ಫ್ರಮ್ ಮೈ ಪರ್ಸ್ಪೆಕ್ಟಿವ್ ಐ ಜಸ್ಟ್ ಟ್ರೈ ಟು ಲಿಂಕ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಓನ್ಲಿ ದ ಫ್ರೇಮ್ ವರ್ಕ್ ಏನೇನು ಇಶ್ಯೂಸ್ ಅಂದರೆ ನಂಗೆ ಈಗ ನೀವು ಆದಷ್ಟು ಬೇಗ ರೆಡಿ ಆಗಿದ್ರೆ ಬೆಟರ್ ಸೊ ದಟ್ ಅಟ್ ಲೀಸ್ಟ್ ಇಫ್ ಯು ಆರ್ ಪ್ರಿಪೇರ್ಡ್ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್ ಕ್ವಶನ್ಸ್ ಆ್ಯಂಡ್ ದರ್ ಕ್ಯಾನ್ ಬಿ ಮೋರ್ ಇಂಟ್ರಾಕ್ಟಿವ್ ಸೆಷನ್ಸ್ ಅದರ ಈ ಥರ ಡ್ರೈ ಹೇಳ್ತಾ ಹೋಗೋದು ನಮ್ಗೆ ಕಷ್ಟ ಆಗ್ತದೆ Okay, we'll see it anyway in the next class. If you have prepared any schedule so that who is taking which topic, so kindly see it in the classroom or on the WhatsApp or on Margaret. And then if some topic is remaining out of whatever you have distributed among yourself, I can directly attempt only that topic. Okay.
Sir, we'll cover that full chapter by V6, sir.
ಹೌದು.
Will not leave any concepts, sir.
ಓಕೆ ಹಂಗಿದ್ರೆ ಅಡ್ಡಿಲ್ಲ ಅಕಸ್ಮಾತ್ ನಿಮ್ಗೆ ಹಂಗಾಗಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಯಾವ್ದಾರು ನಾನೇ ಹೇಳ್ಬೇಕಂದ್ರೆ ಮಾತಾಡೋಣ.
No, sir. No, sir. No, no.
ನಿಮ್ಗೆ ಒಂದು 15 ಕ್ವಶನ್ ಏನು ಶೇರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ರು ಮೇ ಬಿ ಮಧ್ಯಾಹ್ನದೊಳಗೆ ನಾನು ಅದನ್ನ ಹಾಕ್ತೀನಿ ಮೇಡಮ್ ಕೇಳಿ.
Sir, those 15 questions from the which all chapters, sir?
15 ಕ್ವಶನ್ಸ್ ನಮ್ಗೆ ಏನು ಹೇಳಿದ್ರು ಸೇ ಫಸ್ಟ್ 30 ಅವರ್ಸ್ ಇಂದ ಅಂತ ಹೇಳಿದ್ರು ಇನ್ ದ ಸೇಮ್ ಸೆನ್ಸ್ ಟಿಲ್ ಐಒ ಚಾಪ್ಟರ್ ಅಂದ್ರೆ ರೇಡ್ ಆದ್ಮೇಲೆ ಯಾವ್ದು ಬರ್ತದೆ
Sir,
ಕ್ಯೂಯಿಂಗ್ ಥಿಯರಿ ಅಲ್ಲಿ ತನಕ ನಾವೇನೋ ಒಂದು ಹಾಕಿದೆ ಅಷ್ಟೇ. So guidelines were so out of 52 hours syllabus, first 30 hours syllabus should be given as a 15 assignment questions of that.
these are all assignment questions or reference questions, sir?
Okay.
Assignment questions or reference questions, sir?
So I'm recording. I'll just close the recording and then